let me give you an introduction to Math 01, what we'll be covering in this course. So yeah, we're getting used to working with numbers and all kinds of numbers, positive, negative, whole numbers, fractions, decimals, percents, so every kind of number. And we'll also look at some algebra at the end, some beginning algebra with x's and y's. Okay, in chapter 1 we start off easy with the whole numbers. So those are the numbers starting with 0, 1, 2, 3, and so on. And we have the basic operations: addition, subtraction, multiplication, division, also powers and roots. And we'll be combining operations. So here's a kind of a tricky one, where something can go wrong. So 10 minus 4 plus 5. So what's the answer? Did you get 1, or maybe 11, or something else? Well, yeah, here, so for additions and subtractions, yeah, you have to go from left to right, so it's really 10 minus 4 first, that's 6, plus 5. So hopefully you got 11. Okay, so this whole idea of what's the correct order of operations, what's the priority. We'll get into that first. Okay, how about this one? 8 to the power 0. Okay, so a number up here means a power. So what could this be? Is the answer 8 or 0 or 1 or something else? In fact, yeah, the answer here is 1. Yeah, so any number to the power 0 is 1. That's the answer. So in fact, yeah, if you remember that, then it's easy. Okay, down here we have division examples. So what's 0 divided by 8? Yeah, so it's just these little things that can trip you up. This is really asking how many times does 8 fit into 0. And if you think of it like that, it fits in 0 times. This bottom one, we're asking a different question. How many times does 0 fit into 8? Well, it can keep fitting infinitely many times. So the answer here is this is really undefined. Really, you can't divide by 0. That's the only number you can't divide by. And an application of adding and subtracting here. What are the? Can we figure out the two missing sides here? So this, so the total height of the figure. What you can see, it has to be 3 plus 2. So we're adding. How about this side? How far is it between these two corners? Well, the total width is 10. This part of the width is 6. So do you see what this has to be? 4, right? So 10 minus 6 is equal to 4. So we needed a subtraction there. Alright, so that's just chapter 1, our introduction to working with numbers. Of course, we can't ignore the negative numbers to the left of 0 on the number line. And so here are examples of operations with two negative numbers, negative 3 and negative 9. So if you want to add negative 3 to negative 9, what's the answer? Is it 12? In fact, it's negative 12. It's, yeah, in terms of money, you could think of this as you owe somebody $3 and you owe somebody else $9. So does that mean you have $12? No, it means you owe $12. So negative 12. Here's a subtraction. Yeah, then it gets confusing. So this is negative 3 minus negative 6. So we're subtracting negative 9 this time. You could think of this as like taking away a debt, which is the same as getting money. So this is really the same as negative 3 plus 9. So that's plus 6. What's the operation here? Are we adding or subtracting? No, so this situation we're multiplying. Negative 3 times negative 9, and that's positive 27. Okay, yeah, so you certainly get a different answer depending on the operation with these same two numbers. Okay, so chapter 2 will include the negative integers. Chapter 3, yeah, so you can see this course gets more difficult as we go on. So chapter 3, yes, is probably the most difficult chapter, where we look at fractions. So on the number line, where do fractions show up? Yeah, they show up between the whole numbers, between the integers. So the easiest fraction is 1/2. That's halfway between 0 and 1. Here's 1/3. So that's 1/3 of the way between 0 and 1. 2/3 would be here. 1 is the same as 3/3. We'll also look at mixed numbers in chapter 3. So this is 2 1/4, which is the same as 9 quarters, 9/4. So here's 2, and then add a quarter, you get to here. So 2 1/4, that's a quarter of the way between 2 and 3. We need to worry about the operations with the fractions and mixed numbers. So how do you add, for example, 1/2 plus 1/3? Do you just add the tops? 1 plus 1 is 2. Add the bottoms. 2 plus 3 is 5 on the bottom. No, I wish it was that easy. And I know I'm going to see that a lot in the homeworks, but that's not the way to do it. Unfortunately, yeah, it's more complicated, so you need a common denominator when you're adding fractions, so we'll look at that. In fact, the only way to add these is write 1/2 is 3/6, 1/3 is 2/6, So altogether that's 5/6. So we needed an LCD, a least common denominator here, and that's the least common multiple of 2 and 3. So what's the smallest number that's a multiple of 2 and a multiple of 3? It's 6 here, so we needed a 6 on the bottom. Another example of a least common multiple, the least common multiple of 10 and 6. So if you look at all the multiples of 10, so 10, 20, 30, 40, look at the multiples of 6, 12, 18, 24, 30, 36. So the smallest multiple they have in common is 30. So if you're adding tenths to sixths, you'd need 30ths. Okay, a different idea is the greatest common factor of two numbers. So if you look at all the factors of 10, all the factors of 6, the biggest factor they have in common is 2. And greatest common factors, those are useful when you're simplifying fractions, so you can reduce 6/10 to 3/5. Just cancel 2's. Okay, so yeah, we can see when you're working with fractions, then yeah, you need to worry about factors of numbers, multiples. So we really need to see how to break up numbers into smaller pieces, into smaller factors. That's important in chapter 3. Chapter 4, we look at a convenient way to represent fractions, where we have tens on the bottom. So 7/10 as a decimal is 0.7. 3/1000, 3/1000ths as a decimal is 0.003. And the idea is you look at so the number of places of the decimal, that's the number of digits to the right of the decimal point. So this decimal is one place, so that means we just need 110. This decimal has 3 places, so we need 10 times 10 times 10. Yeah, here we have a decimal with 3 places, but well, so why is this decimal 0.125 equal to 1/8? Well, what do fractions mean? Well, the fraction bar means really division. So this is really 1 divided by 8. And when you do the division, so we'll look at that, you get this answer 0.125. Yeah, I mean, you can see that 8 fits into 1 0 times, but in terms of whole numbers, but it fits in really 1/8 of a time, so we get this decimal. In chapter 4, we also look at percents. So here's a percent, 12.5%. We can convert this into a fraction or a decimal. As a fraction, it's 125 over 1,000. which reduces to 1/8. So in fact, yeah, so these are all representations of the same number. Okay, so we can see, we're looking at numbers from all different angles, so these are all really the same number. So that makes it confusing. Okay, more fractions in chapter 5. So a third way to think about fractions is in terms of ratios, where you're comparing two numbers. So 3/5 as a ratio, you're comparing 3 to 5. A proportion is a situation where you have two ratios that are equal, or in other words, two fractions that represent the same number, equivalent fractions. So this is a proportion. These represent the same number. If you reduce 6/10, you get 3/5. You could have this situation. So this is a proportion with one of the numbers missing. So 3/5 is equal to 6 over something. So that something has to be 10. So that's finding the missing number. That's called solving a proportion. And that has all kinds of applications we'll look at in chapter 5. So percent problems, word problems. And this is our first example of an equation. So this is solving an equation, finding the missing number. And we get into that more in chapter 6. So chapter 6, the last chapter, we do some beginning algebra. So we have letters representing numbers. X and Y we'll use, also A and B, so any letter. So something like this. So this first example, compute x to the power of 3 minus 3x plus 7 if x is equal to -2. And the idea here is we're just substituting, so just every x gets replaced with a -2. Okay, and then we can work this out. So a -2 to the power 3, that's going to be -8. Here we have -3 times -2, that's plus 6. -8 plus 6 is -2. And then add on the 7, we get 5. Alright, so that's called evaluating an algebraic expression. The answer is 5. Alright, so that's basic algebra. The other thing we'll look at is solving linear equations. Okay, there was no equal to here, but this is an equation. And so the question here is, can we solve it? Can we find what number goes in for x to get a true equation, to get the left side to equal the right side? One way to solve these is to try to guess the number. How about x equals 0? Does that work? Well, if you put in 0, you get 6 on the left and 20 on the right, so no, that doesn't work. They're saying here the answer is 2. So does 2 work? So 3 plus 2 is 5 times 2 is 10. -5 times 2 is -10 plus 20. So when x is 2, we're getting 10 equals 10. So that's the solution, and yeah, it turns out these linear equations, well, usually just only have one solution. Okay, so that's the last thing we'll be covering. Okay, so yeah, you can see we're working with fractions a lot. This course, yeah, does start off fairly easily, so don't be fooled. Okay, but just to give you an idea of what we'll be looking at.